The math module in Python is a standard library that provides a wide range of mathematical functions and constants. These functions help perform mathematical operations such as calculating powers, square roots, trigonometric operations, logarithms, and many more. The module includes constants like pi and e, which are fundamental in various mathematical computations. By using the math module, you can simplify complex mathematical tasks in your programs, making it easier to perform calculations accurately and efficiently. In this video, we'll explore some of these functions and see how they can be applied to GIS data. So let's head on over to PyScripter. Okay, so we're in PyScripter. I'm going to open up a new script and of course remove the default code. And we're going to start by importing the math module. So we use the import keyword and math. And we have seen this previous in the course. And we'll first take a look at using a constant. And the constant we're going to look at is pi. We're going to use pi to calculate the circumference of the Earth if we are modeling the Earth as a sphere. If you search the internet, you will find that the radius of the Earth is around 6,371 kilometers. So we'll create a variable called radius and we'll set this to equal 6371. And to get our circumference, the formula is 2 times pi. So we have math.pi, and this is our constant. If I head over to the interpreter window and I import math over here, and then I print math.pi, we can see we get pi. Go back over to our equation, we then multiply that by the radius. And we want to print, we'll use string formatting, circumference of the Earth, and we'll put in our circumference variable and follow that with km per kilometers. Now when I run, we can see circumference of the Earth is around 40,000 kilometers. I'll clear the interpreter window and I'm going to comment out our current code. In our next example, we are going to calculate the distance between 2 points using the Pythagorean theorem. We'll create an x1 and a y1 as coordinates, and we'll set these to equal 715,830 and 734,697. That is somewhere in Dublin in Ireland using Irish Transverse Mercator coordinate system. And we'll have an x2 and a y2. I'll set this to equal 567965 and 571760, and that is somewhere in Cork in Ireland. So we're going to get the distance between Dublin and Cork. We'll create a variable called distance and we'll set this to equal math.sqrt, which is the square root, and we use parentheses, and within these parentheses we want to use math.pow, which is to the power of, and we want to use this twice to add. So we'll call math.pow, and in the parentheses for our pow we're going to say x2 minus x1 comma 2. So what this is saying is x2 minus x1 to the power of 2. So x2 minus x1 to the power of 2. And we want to add in a plus. And we're using power again, math.pow. And this time it is y2 minus y1 and again to the power of 2. So this here is our formula for calculating the distance on a Cartesian plane. The formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We'll add a print function. We'll use string formatting. Distance between Dublin and Cork is distance, and that is in meters because our ITM is in meters. We'll click run, and we can see that the distance between Dublin and Cork is 220,000 meters, so 220 kilometers. We'll clear the interpreter window and we'll take a look at another example. We can calculate the angle of elevation between 2 points. Let's say we know the points and we know the elevation difference. So say the elev diff equals 500 meters, and we've already calculated the distance between the 2 points, and that is a kilometer apart, 1000 meters. Now we want to calculate the angle of elevation. Set that to equal math.degrees because it's an angle, so we want it in degrees. And we use math.atan, and we supply in our elev diff divided by our distance. The atan function is the arctangent or inverse tangent of a number, and the returned angle is returned in radians, hence why we are converting to degrees. Now, I am no math expert. I look up these formulas beforehand. I've had to use mathematical formulas from time to time. They're not embedded in my brain. I looked them up on the internet and then apply them in Python. We will print the angle of elevation is our angle elev in degrees. We'll run. I can see we get 26.56 degrees. Clear the interpreter window and I'll comment out our code. There are other math functions for rounding. We have ceil, floor and trunk. Math.ceil will round a number, a decimal number, up to the nearest integer. Math.floor will do the opposite, and it will round our decimal or our float down to the nearest integer. And math.trunk will just return the integer part of the number. So let's take a look. We will create a num and set this equal to 8.78. We'll create a variable called ceil and set this equal to math.ceil. And we want to supply in our num. We'll then create floor. Set this equal to math.floor. Again, we supply in our number. And our trunk. Set that equal to math.trunk. Supply in our number. And we will print all three. We'll print ceil, floor and trunk, and we'll run and see what our output is. So we can see 8.78 with ceil was rounded up to 9, floor was rounded down to 8, and trunk just removed the decimal place and returned 8. In this video we took a look at the math module or library, which is part of the standard Python library, and we can import into our scripts. The math module performs various mathematical calculations, and I would encourage you to explore this module further for advanced GIS applications. The math module allows basic mathematical functions that we saw with math.py, and we also saw using the square root and the power of with exponentiation. It offers trigonometric functions, and we saw this using atan when we calculated the angle between 2 points based on its elevation. We finished up by looking at some examples using rounding. Rounding could be very useful when you are dealing with coordinates. Often you will have superfluous amount of decimal places in your coordinates, and you might be performing analysis where the decimal places are just overkill and you need to round to the nearest integer.